research, Riswat. Time is
Yes, of
yours.
course. Before that, can you hear my voice?
Yes, of course, clearly.
Okay. Hello, everyone. My name is Kirana Anindya Larasati, and these are my partner.
I'm Sabrina Dewi Anggraini.
I'm Rianti Putri Fakiha.
We're Group 1 from Indonesia, and today we're gonna talk about the design of hydrogen gas storage produced by water electrolysis as an alternative fuel source.
So this is the research background. Our research is related to Sustainable Development Goal SDGs number 7, namely affordable and clean energy. Fossil fuel reserve running low. Indonesia needs energy reserve that can be used in the future. One of the new renewable energy is hydrogen energy. Based on statistical data, Indonesia has potential to develop hydrogen energy.
So, how to produce hydrogen gas? How to design the hydrogen gas storage? Can energy from hydrogen be developed in Indonesia? All of the questions will be answered in our research.
And this is the research method. The tools and materials that we use for our experiment are static and clamp, U-shaped tube, pipettes, cable and alligator clips, graphite electrode, panel, natrium sulfate solution, phenolphthalein, and battery. And this is the step. First, attach the U-tube to the clamp. Put 90 ml of natrium sulfate solution into the U-tube using a panel. Attach to graphite electrode to the alligator clips. Insert the graphite electrode into each side of the U-tube. Connect the alligator clips to the battery. Observe the changes that occur. Draw phenolphthalein indicator into the solution on both sides of the U-tube and observe the changes that occur. From this electrolysis experiment, we design a hydrogen storage device.
So these are our experiment. We can see the reaction when the phenolphthalein drop into natrium sulfate solution and the bubbles in cathode and anode. And these are the electrolysis results.
The pH before the graphite electrode is dipped in sodium sulfate is 7, and after dipping the graphite electrode, the pH in the anode chamber or graphite electrode connect to the positive pole of the battery is 5, and the pH in the cathode chamber or graphite electrode connect to the negative pole of is 12. The bubbles produced by the anode chamber look less than the cathode chamber because the anode chamber produces oxygen which will be dissolved in water, and the cathode chamber produces hydrogen. Then, when the phenolphthalein indicator is shipped into the anode and cathode chambers, the anode chamber will turn white because the anode chamber produces H plus ions which is acidic, and the cathode chamber turns pink because the cathode chamber produces OH main ions which is basic. And this is our design of hydrogen storage. The storage of hydrogen gas from electrolysis utilize the concept of hydrostatic pressure. The gas collected above the surface of the water at the cathode chambers flows into another bottle. Then the hydrogen gas will move to the top of the water surface because hydrogen gas is nonpolar, which is insoluble in water, and gas moves from high pressure to low pressure.
So next, this is our conclusion. First, this hydrogen is easy to be produced. So hydrogen can be produced from many feedstock and process. One of them is produced from water, and one of the ways to produce it is by electrolysis. Second is the hydrogen storage. So even hydrogen is gas, we can still can accommodate this hydrogen. And our hydrogen gas storage design utilizes the concept of hydrostatic pressure. And third is the potential of hydrogen as an alternative energy in Indonesia. 62.
The sound is missing. Suaranya hilang, Pak Yudi. Please check again the audio.
Hello.
Okay. So please continue just a little bit more.
So the third conclusion is the potential of hydrogen as an alternative energy in Indonesia. 62% of Indonesia area is sea and water, so hydrogen as an alternative energy is certainly not a difficult thing to utilize in Indonesia. Oh my gosh, I'm so sorry. Can you hear my voice now?
Yes,
So
yes, yes. Please continue.
So 62% of Indonesia area is sea and water. So hydrogen as an alternative energy is certainly not a difficulty to utilize in Indonesia. Unless it's our difficulties and limitations, our research only designs hydrogen gas storage devices based on small lab experiments. It has not been tested how to utilize the hydrogen gas that has been stored, and this could be the material for further research. And thank you for listening us. Is there a question? And once again, thank you.
Okay, thank you. Dr. Thomas, do you have any questions to this group, please?
Yes, this is fascinating to see that you're using electrolysis to separate oxygen from hydrogen from water as a way to create fuel. Hydrogen is a wonderful fuel source. However, it can also be very combustible. It can explode, and storage, safe storage can be very important. How do you propose to store that fuel safely so it doesn't burst into flames or catch fire or explode in areas where we need to use it?
Okay. So please answer. Do you need translation?
No, thank you.
Okay.
So first, I'm gonna tell you that I'm sorry for our difficulties and limitation that we just designed the hydrogen storage for base small experiment in lab. So we don't know how to. Can you translate this?
Pertanyaannya, hidrogen itu kan memiliki sifat juga untuk bisa meledak kalau penyimpanannya tidak baik. Maka Profesor Thomas menanyakan kira-kira penyimpanan yang baik yang bisa membuat agar si hidrogen ini tidak mudah meledak. Tidak meledak, karena kalau memang hidrogen itu tidak disimpan dengan baik, maka dia akan jadi bom.
Okay. Ms. Irma, can you translate our answer? Because I want to answer in Indonesia. So, mungkin untuk agar si hidrogen ini bisa disimpan dengan aman, bisa dari bahan untuk penyimpanan hidrogennya yang cukup kuat, dan mungkin ini juga salah satu dari difficulties kita, di mana kita hanya bisa mendesain hidrogen ini berdasarkan penelitian kecil, jadi belum terpikir hingga sana.
Okay, so Dr. Thomas, they said that they thought that the storage should be strong, so it cannot make the hydrogen become combustion and then easy to blow up. And then, but they said they didn't think about what kind of storage the strong storage is. So it would be there for the research considerations for their futures. And then they will say sorry because this is also the limitation and difficulties. They only trying to conduct some small experiment related to this one. I think this is the big challenge also for them in the future.
Thank you very much. I understand storage is always one of the biggest issues when we look at fuel.
Okay, thank you. And then Dr. Tanya, do you have questions?
Thank you so much. Like the water electrolysis is, I think it is one of the, it's a simple way to make a hydrogen gas, right? But anyway, do you have studies about amount of hydrogen that we need in at least to make something to move, for example, like toys car to move, or even like, I'm not sure, the motorcycle, how much energy that, like hydrogen gas that we need to give enough energy to make something to work.
Okay.
Yeah.
Berapa banyak hidrogen yang diperlukan untuk bisa dijadikan sebagai energi, contoh dalam menggerakkan mainan atau misalkan motor? Kira-kira sudah ada riset sebelumnya enggak, atau kamu coba find some data gitu terkait dengan itu? Kira-kira hidrogen itu berapa sih yang dibutuhkan gitu?
We know this is difficulties and limitation for our research, and this measuring hydrogen to can I speak in Bahasa?
Yes, please.
Dan kita belum bisa untuk mengetahui bagaimana berapa hidrogen yang bisa untuk seperti motor atau kendaraan lainnya, karena itu kita research, kita plan untuk future research plan sebagai first made hydrogen gas measurement device, and wanted to find out more about what hydrogen has to do become as well has how much hydrogen is needed to make fuel.
And mau nambahin sedikit, jadi menurut kemarin kan penelitian di lab bersama Pak Omai, jadi setahu kita tuh informasi yang kita dapatkan adalah di mana hidrogen ini dengan 18 gram air kita bisa menghasilkan sekitar 185 kilojoule. Jadi mungkin ke depannya kita bisa mencari tahu berapa yang dibutuhkan, tapi yang jelas dengan 18 gram air tersebut kita tahu sudah bisa menghasilkan sekian joule gitu.
Berapa joule?
Sekitar 185.
Okay. Okay, so Dr. Chanya, they said that based on the experiment, actually they didn't know how much energy of hydrogen that they need to move a car or to move a toys. However, from the experiment, they said that from 8 grams of water, it could be produced around 180 joules of energy. And based on this experiment result, maybe in the future they can to find out how many, and then they can trying to find and then also to simulate about the comparison of water and then also the sum of the energy that produced from the water. Maybe this has become their future research also.
Okay, thank you so much. Actually, sometimes we might don't need to think about the storage, right? Like if you can put this thing in the machine or the thing that you want to move, sometimes you can just like continually produce and use this like on one process. I think it is another way, because when we store the gas, especially it need a lot of like higher pressure. And we need to think a lot about the combustion, like the explosion, not combustion. It's like it's exposed as well if you keep the hydrogen gas storage and it's not in the safe place. Okay. Thank you.
Thank you. And then for the last time, please, Professor Gillian, do you have any comment related to this research?
Yes, thank you. I really enjoyed your presentation. I used to be a high school chemistry teacher, so it was really exciting to see a chemistry project and how carefully you had conducted that experiment and that you were able to isolate the hydrogen gas. You also really highlighted in both your presentation and your answers to the questions that you were asked something really important about engineering, that one of the important steps is that we design things in a small scale in the lab. And you were really clear that there's more work that needs to be done to scale that up and understand some of the problems that might happen there. So I was really impressed with your understanding of how it's important to think about how we move from small scale to large scale. So really nice job. You should be very, very proud of the work that you did.
Okay, thank you very much. And then this is maybe the end of the first session. So we will move to the break time, right? I will return it to Yoshimura-san. Yoshimura-san, please.
Yep, thank you very much. So now we are going to have a 10 minutes break. So right now, 10:05. So